Hi guys, welcome back to the channel. Jag here. In today's class, we're going to continue with our Math 10 content. And today's topic is going to be on verifying the properties of triangles. So with that, let's get started. Okay, so here we are. And I just put down properties of triangles. So let's try this question here. Okay, it says basically to verify. I'm going to put that triangle, okay, ABC. Is isosceles. Okay, so when we are verifying this, what we're going to do, I'm going to give you the values or the actual vertices here. Okay, so A is 4 and 2. B is -2, -2. Okay, and vertices C is 2 and -8. Okay. So now say I'm doing this question, okay, I should actually graph out, okay, the actual triangle here, okay. That's just so you can see maybe like just a quick sketch here, okay, of this triangle. However, in this case, I know I'm just going to be using the length formula to find all three sides, okay, eventually. Okay, so in this case, actually, if it just says to verify this triangle is isosceles, you don't really need to sketch this out. Okay, I'm just going to sketch it so everyone can see what the triangle looks like. This is B, -2 and 2. Okay, and then C is actually 2 and -8. Okay, so this is where point C is like this. Okay, and you can see that it didn't take me that long to actually draw just a quick sketch of the triangle, just so we know what we're dealing with. When you verify various properties of triangles, okay, the question can be just slightly different. I can check whether two sides are parallel, are the midpoints parallel as well. Okay, the teacher will just change around the question just to try and trick you. Okay, so let's try this one here. When we're verifying that this triangle is an isosceles triangle, what we're going to do is let's find the side length. Okay, so I always number it again. Okay, so let's do the length, okay, of AB here. Okay, so when you do the length of AB, I always just write AB equals. I'm going to write out the formula here. Okay, so everyone remembers what the formula is for the length of a line segment. So x2 minus x1 squared plus y2 minus y1 squared. Okay, and we're just using our points A and B here. Okay, again, if you get confused, I would just make sure that I maybe like label it. Okay, so I'll label it for this one. So x1, y1. This is x2, y2. Okay, and you have to change the labels, okay, as we do each side of the triangle. So let's substitute it in here. So I'm going to make sure you put the square root sign going all the way down. Okay, so x2 here, which is -2. Minus x1, okay, which is equal to 4. Everyone see that? So we're doing -2 minus 4, and then you square it. Okay, and then we're going to do y2, so -2 minus y1, which is -2. And then we'll square that as well. Okay, everyone's good so far? Make sure you're adding, okay, in between here. Okay, so I'm just going to do square root. So this is -2 minus 4, -6 squared, which is 36. -2 minus 2, and then I'm squaring this, which is -4 squared. Okay, which is equal to 16. Does everyone see that? We're going to add these numbers together here. I'm getting square root 52. And again, if you want to do the exact value, okay, it's equal to 7.2. Okay, in most cases, you could just leave your answer like this, okay, as the square root 52. It should be all right. Okay, let's write the next one here. Let's do the length, okay, of the next side. So I'm going to put length of, we did AB, let's do BC. Okay, and then we'll put the square root sign one more time, okay. What we're going to do is B and C, okay. So just change around your values here. Okay, so we're going to do x2 minus x1. Okay, or whichever way you want to do it. Let's do it the other way around. So 2 minus negative 2 squared plus, okay, and we're going to do the y2 minus the y1 squared, okay? So remember, again, it doesn't matter which point is the first point or the second point. Just make sure you don't switch it around, okay, in the middle. Okay, so I'm going to take the square root here. This is 2 plus 2, so 4 squared, 16. Okay. In this bracket, negative 8 plus 2, so negative 6 squared, which is equal to 36. Everyone see that? And again, I notice I'm getting square root 52, which is equal to 7.2. Okay. Now remember not to just find the length of two sides, okay? I want to make sure I'm finding the length of all three sides in this case, okay? So we have some room here. Let's do the length of this last side. So the length of side CA, okay? And I do want to make sure I find the length of this last side, okay? Because what if this last side is actually equal to the other two sides and it's also equal to square root 52? That would actually indicate that this is an equilateral triangle. It wouldn't be isosceles at this point. Okay, so it is really important that we do find the length of all three sides. Okay, again, it's good to make the actual diagram, okay, so we can see what we're dealing with. So now we're doing the length of this last side here. Okay, and we're going to substitute it into the same formula. Okay, so we're going to do x2 minus x1. I'm going to square that. Okay, plus the y2. Okay, so this is the y2 here, negative 8 minus y1, which is equal to 2. Okay, and I'm going to square that. Does everyone see that? Again, make sure you are double checking or maybe just like label the points, okay, as you put it into the formula here. Okay, so we're doing 2 minus 4. So let me put one step in between here, which is negative 2 squared plus, okay, and then we're doing negative 8 minus 2, so negative 10 squared, okay? So negative 2 squared is equal to 4 plus negative 10 squared, which is equal to 100. This is the square root, okay, of 104. I'm going to put it in my calculator, and we're rounding it to one decimal place. So 10.2, okay? Actually, what you should be writing here is just units. Okay, and the reason we're putting units is basically because this is analytic geometry. Okay, and basically it's units on the Cartesian plane. Okay, and that way you could just leave it like this. It's not like centimeters or kilometers, unless it's an application question, okay? In that case, it might be maybe the distance, okay, between like your house and the school, for example. Okay, and the answer would be in kilometers. Okay, but again, the question does have to indicate that. All right? Are there any questions here? All right, so that looks good. Okay, so let's do one more example here. Okay, so I'm going to take this off. And what we're going to try here is this example, okay? So it basically gives you this triangle, okay? And it says verify, okay? And I will show you just a diagram of it. But let's try the actual values through the analytic geometry. Okay, so again, even when you're verifying, okay, a triangle that is isosceles, I can't just like draw it out and say that it looks like it's isosceles. We have to use the mathematical formulas, okay, in order to prove it. So verify that PQ is twice, I'm going to put the length of ST. I'm going to give you like the values. So this says ST here, okay. So the P point is basically 2 and 4. Okay, and the Q is negative 4 and negative 6. All right. And then I'm going to give you the values for ST as well. S is 7 and 2. and I have t here, which is 4 and negative 3, okay? And I will show you a diagram, okay? It is in the textbook here. Okay, we're verifying that PQ is twice the length of ST, okay? So let's do the length here. So I'm going to put length of, okay, PQ. Okay, and then again, one more time, let's plug it into the formula. Let's write the formula out here. Anytime you do substitute, okay, into the formula, I want to make sure that I write out the formula here. Okay, just so the teacher can make sure when they're marking, or he or she is marking, she can see and make sure you're using the right formula here. Okay, and I'm going to label this actually, because we're only going to use the points once. This is x2, y2, okay? So we're going to do x2, so minus 4, minus x1, which is negative 2, and we're going to square that. The second point is y2, which is negative 6. And you notice here y1, which is 4. Okay, make sure you're very careful, okay, in terms of the signs here. Let's put one step in between. Okay, so this is negative 4 minus 2, negative 6 squared. Negative 6 minus 4, negative 10 squared. Okay, remember to use your calculator, okay, as you're doing each of these calculations. There should not be any mistakes in terms of the signs. Negative 6 squared is equal to 36, and negative 10 squared is equal to 100. So we're getting square root 136. So I am going to put this into my calculator, okay, because we want an exact value here. So let's round this. So 11.7 units, okay. So this is the units and the actual length for PQ, okay. So let's go to, let's put length of, okay, ST here, all right. Let's label it. So x1, y1, this is x2, y2. Okay, and the reason we label it like this is point 1 and this is point 2. So I want to do the length here. So let's do square root. Okay, and we're going to do x2, okay, which is 4, minus x1, which is 7. I'm going to square it, okay, plus y2, which is negative 3, minus y1, which is 2. I'm going to square that, okay? And we're going to take the square root here. So 4 minus 7, negative 3 squared. Okay, negative 3 minus 2, which is negative 5. Now I'm going to square that. Okay, make sure you're showing all of the steps, okay, as you're doing the question. Negative 3 squared is 9. And negative 5 squared is equal to 25. Okay, and we're going to add that together. We're getting square root of 34. Okay, which is 5.8 units. Okay, so again, I'm just rounding it, okay, to 2 decimal places. Or as in 1 decimal place. Okay, just to keep it accurate. Now, you see, for ST, the length we got was 5.8. And the length for PQ is 11.7. Okay? We were verifying that PQ is twice the length of ST. So we're just going to do it right here. 5.8 times 2. And we're getting 11.6 units. Okay, so again, this is just like rounded. Okay, because we did round the value here for square root 34. Okay, if you rounded it to 2 decimal places, it would give you an exact value here of 11.7. Okay, does everyone see that? And this was actually basically like a triangle here, okay? And we did this question from the textbook, okay? It was a triangle and it was actually giving you both the lengths here, okay? So if you want to just take a look, quick look here. This is number 3 in the textbook. This is the Principles of Mathematics, page 125. Okay, so you can see that the diagram is given to you. Sometimes the diagram isn't given, okay, and you actually have to solve for the, actually graph it out, okay, and find the midpoints here. Okay, you notice that S and T are basically the midpoints of these opposite sides. Okay, and then they're just basically joined together. Okay, and that's how you actually verify that PQ is twice the length of ST. Okay, and notice that I just put it into the length formula here, and I just found the length of both of the sides. Okay, and both of these lines. Okay, and there should be like a therefore statement. Okay, so let's put like therefore. I'm going to put therefore the length, okay, of PQ is twice the length of ST. Okay, so just like this. So you notice I do have to show this last step, okay, so the teacher can see that you actually proved whatever was asked of you. Okay, all right, so that looks good. And if there are no questions, that does bring this video to an end. Thank you so much for watching. Please make sure you do like, share, and subscribe to the channel, and I will see everyone in the next video. Thanks, bye.